Hello friends, so today I will discuss about probability, which has great applications in machine learning and deep learning, and I will come to those applications later. Today I will basically give you some basic idea of probability, what is random variable, what is discrete random variable, something like that. Before starting the lecture, I would like to say you two things. First, if you like the video, then please subscribe the channel and don't forget to hit the notification bell so that whenever a new video will be uploaded, you can get the automatic notification. Okay. And the second thing is that if you feel to give any kind of feedback to that video, then please feel free to do that in the comment section so that it will help me to improve the videos in future. Now let's get started. So basically, first I will discuss about random variable. What is random variable? Random variable is a function that assigns each real number to a sample point in the sample space. Okay. For example, here, suppose here I have given example. Suppose suppose I toss a coin 3 times. Okay. Then what are the possible outcomes? Okay. Here in the definition, what I said, that this is a function that assigns each real number to each sample point in a sample space. Here basically I have used two things. One is sample point and another one is sample space. So I will discuss what those things are. Okay. So here just see that if I toss a coin 3 times, what are the possible outcomes? Head, 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 tail, head, or something like that, right? So what is sample space? Sample space is the set of all possible outcomes. Suppose here I toss 3 coins, then what are the possible outcomes? Head, 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 tail, head, and this basically these 8 possible outcomes are there, right? So this set is, this is called sample space. And what is sample point? Sample point is each point, that is head, 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 right? If I suppose denote it by S1, suppose suppose I denote it by S1. Okay, so this is a sample point. Suppose I denote the next one S2, then this is a sample point. Okay, now what is random variable? Here I denote the function that x is number of heads. Okay, so what will be x of S1? X of S1, tell me. Here number of heads, how many heads are there? 3 heads. Head, head, head. Okay, so this will be 3. Yeah. And the second one, here there are 2 heads. Okay, so the head will be 2. So 3, 2, these are real numbers and S1 is a sample point. The definition is, this is a function that assigns each real number to a sample point in the sample space. I hope it is clear now. Okay, now just a minute. Yeah, so this is random variable. Now we will know about discrete random variable. Basically there will be 2 kinds of random variable. One is discrete, another one is continuous. Let's learn about them one by one. Okay, so what is discrete random variable? Discrete random variable is a random variable which has countable number of values. For example, if I toss a coin 3 times, then what are the possible outcomes, right? The possible outcomes are finite. So if the possible outcomes or the values are finite or countable, then that is said that discrete random variable. For example, number of heads. Number of heads, the previous example, right? So this is the discrete random variable. Now if I say, just think about it, if I say that the weight of all the persons in a city, is that will be a discrete random variable? What I said, that the random variable which has countable number of values. Now the set of all persons, the set of weights of all persons in a city is not countable. Why? Because suppose a person has weight 65.5, right? What is basically countable number? Countable number means it has a bijection, it has a one-to-one and onto mapping with the set of natural numbers, right? If it is infinite, either it is finite, or if it is infinite, then it has a bijection with the set of natural numbers. Now this set, that the set of all peoples, weight of set of all peoples in a city, this is not a discrete random variable, okay? And we will see later that this is continuous random variable. Now let's come back to the next result. What the next says? Next result says that probability distribution. Okay, so yeah, I will give the example, but before that, just remember one thing, that this is basically the description how a random variable is going to take each of its values. Okay, for example, the first example that I give, that whenever we toss a coin 3 times, okay, if I add a probability with that, that is what is the probability of getting 1 head or 2 head or 3 heads or no heads at all. So that thing is called, here you can see that thing is called probability distribution, right? X of s comma p. Here this is a description of how likely a random variable is to take each of its possible value. Here the random variable is x of s, and how likely it will take. So that is the probability. So that is called probability distribution. Again, there are 2 ways in order to describe a probability distribution. If it is discrete, then that will be probability mass function, and if it is continuous, then that will be described by probability density function. Okay, before that, just let me give the example. Let me give you the example. Here the s, so s is the number of all coins of head. I mean, if we toss 3 coins, then the number of heads. So now probability of S1. What is S1? S1 is 3 times head. And how many options are there? So basically there is only one option, right? And what is the total point of sample space? That is 8. So that will be 1 by 8. Okay. Sorry, just a minute. What I am doing there? Okay, so first one is number of heads, right? Number of heads, and here this is 0. So basically number of heads, that is 0 number of heads, right? So that will be that everything will be tail. So tail, that is one possibility, and total outcomes are 8. So that will be 1 by 8. Now number of head is 1. So let's go to the example and see how many numbers are there. Number of heads are 1. This is the example, right? Here number of heads are 1. That means tail, head, tail, head, tail, head, tail, tail. So basically there are 3 possibilities. Okay, now this is 3 by 8. Similarly, number of 2 heads, that again will be 3 by 8. Now number of 3 heads, that will be head, head, head. So that is 1, and the total sample space, there are 8 points. So that will be 1 by 8. Okay, so 1 by 8. One interesting thing, if you sum the total numbers, then you can see that that will be 1. Okay, anyway, let's come to the next. So just like I said, that there are basically 2 ways to say about this probability distribution function. Now if it is a discrete random variable, then that is the values are either continuous or finite, then we will discuss about probability mass function. Okay, now what is that probability mass function, or how we should define it? Suppose x be a discrete random variable, then pi is said to be, p of x equals to xi equals to pi is said to be probability mass function if it satisfies two conditions. What are those two conditions? Number one is pi greater than equals to 0, and number two is summation pi equals to 1. In the above example, you can see that this is basically a probability mass function. Why this is a probability mass function? Because here the values are finite. So it is a discrete random variable, right? Now it is discrete random variable, and if I see the values 1 by 8, 3 by 8, 3 by 8, 1 by 8, everything is greater than equals to 0 and their sum is 1. So this is a probability mass function. Okay, now let's come to the next. Okay, there is another example I have given here. Consider a single discrete random variable x with k different states. Okay, consider a single discrete random variable x with k different states, and the uniform distribution we define by setting the probability mass function p of x equals to xi equals to 1 by k. That is, each events are happening equally likely, right? So p of x equals to xi equals to 1 by k. Now, is this a probability mass function? The answer is yes. Why this is a probability mass function? Because here p of x equals to xi equals to 1 by k. So each 1 by k is greater than equals to 0, and if I sum it, total number of events is k. So if I sum it k times, that will be 1. So this basically satisfies the two properties of probability mass function. Okay, now the next point. What is the next thing? Well, the next thing is continuous random variable. What is a continuous random variable? A random variable which can take infinite or uncountable number of values in the interval is said to be continuous random variable. Okay, suppose here, just see the picture. I take a interval 1, 2. Okay, and there is a random variable that take continuous number of values, right? Basically, geometrically we understand that continuous number of values in a real interval means that there will be no break, right? Though there are other definitions, but this is just in order to get the intuitive idea of this. So a random variable which can take infinite or uncountable number of values in the interval is said to be continuous random variable. Okay, let me give you one example. The example is set of weights or height of people in a city, right? Of people in a city. Okay, so we can think this way, that this is a continuous random variable, because see what happens. In a city, people's weight can vary from any number, right? 60 to 70, 60.1, 60.2, and this set is clearly not finite, because even the number of people is not finite in a city. And the second thing is that this set does not have any bijection with the set of natural numbers, so this is not countable also. So this random variable is said to be continuous random variable. Now for discrete random variable we use probability mass function, and for continuous random variable we will use probability density function. Okay, so what is this probability density function? Let me give you the definition. A function P is said to be, or f is said to be probability density function if it satisfies these two conditions. Number one condition, f of x greater than equals to 0 when x lies in this interval. And the second condition, integration minus infinity to infinity f of x dx equals to 1. Okay, so basically this is the probability density function. probability mass function P has to satisfy that condition that P is greater than equals to 0 and summation Pi equals to 1. But for probability density function, f has to satisfy f of x greater than equals to 0 and integration minus infinity to infinity f of x dx equals to 1. Okay, simple, right? So let me give you one example of probability density function. Hello friends, so today I will discuss about probability, which has great applications in machine learning and deep learning. I will not, and I will come to those applications later. Today I will basically give you some basic idea of probability, what is random variable, what is
and define this
random
function
variable,
this way,
something
that
like that.
x u x a
Before
comma
starting
b
the
equals
lecture,
to
I would like